Today I want to start off by pointing out that I wrote down the ratio test upside down yesterday, and I didn't even notice until today. When I had an argument myself, that started off by saying, that's the way you wrote it yesterday. So this is going to be the limit from the ratio test. Limit as n goes to infinity of the absolute value of an plus 1 over an. And we're going to compare that limit to 1. That limit is less than 1. Then we say that the series is absolutely convergent. If that limit is greater than 1, then we'll say that the series is divergent. And if that limit is equal to 1, then the ratio test is not going to tell us anything. We have to go do something else. We don't write no conclusion. We just write go do something else. Really, it should say is if the limit from the ratio test is equal to 1, you need to go back and do the limit comparison test. What are you doing? You don't use the ratio test on rational or radical functions. That's what the limit comparison test is for. So one of the things that we're doing here is we're putting the ratio in absolute value sign. This is because we're making a comparison with 1 that's greater than 1 or less than 1. And if we keep the signs, if an plus 1 is negative, where an is positive, that ratio will be negative, regardless of whether the series is converging or diverging. So we don't want this limit from the ratio test to be trivially negative for our purposes. That's why we do the absolute value. The other thing that we like about the ratio test is that gives us a very strong result. Absolute convergence. So this is the better convergence. So that means that we need to talk about the other kind of convergence. And we need to talk after we talk about the ratio. We made a note of some things yesterday. The ratio test is good for series where the terms have factorial or exponential factors. The ratio test is best for series with exponential and factorial factors. The ratio test is blind to polynomial and radical factors. That means if we just have a rational or a radical function and we run it through the ratio test, we're going to get 1, which means go do something else. So here is a series, and the term has an exponential factor. That 2 to the n is an exponential factor. So this is going to be a good candidate for the ratio test. We're also in this example going to see how the ratio test ignores rational and radical factors. So the pieces that we need are an and an plus 1. So an, that's just the term n squared over 2 to the n. An plus 1 will be n plus 1 squared over 2 to the n plus 1. So we're going to do the ratio test. We'll take the limit as n goes to infinity of the absolute value of an plus 1 over an. So we're going to do the top times a reciprocal of the bottom. So, and then a bunch of cancellation is going to happen, or some cancellation is going to happen. How we'll typically write this, since this takes up so much space, this complex fraction business. Instead of dividing by n squared over 2 to the n, we'll multiply by the reciprocal 2 to the n over n squared. Here's what's going to happen with those exponential factors. Notice I've got a 2 to the n over 2 to the n plus 1. So if I have 2 to the n over 2 to the n plus 1, we'll end up with just a half, because 2 to the n cancels out. If I have 2 to the 5th over 2 to the 6th, 5 of the 2's cancel out, I got 1 half. 2 to the 10th over 2 to the 11th, 10 of the 2's cancel out, I got 1 half. You can also remember that 2 to the n plus 1 means 2 to the n times 2 to the 1. Either way, we're left with a half. Furthermore, when I simplify that part of this limit, 1/2 doesn't have any n in it anymore. No longer has anything to do with n. So I can pull it out of the limit. It's just a constant times the limit. No longer has anything to do with n. The 2 to the n part canceled out. Left us with a half. So we're going to pull that aside. And what's left is limit as n goes to infinity of n plus 1 squared over n squared. Since they're both being squared, they're both positive, so I don't have to worry about the absolute value sign. Also, the sum starts off at 0 and goes to infinity. Notice that n equals 0 is no good here in the limit, but it's perfectly fine in the series, because that'll just give us 0 over 2 to the 0. That's the fine. And the next one will be 1. Sorry, yeah, 1 over 2 to the 1. But we can drop the absolute value signs because these n's are all positive. Also, they're both being squared, so there's not going to be anything negative anyway. So what we see here is I've got an n squared over another n squared. So the limit goes to 1. This limit goes to 1. The n part of the limit so the limit from the ratio test is equal to 1/2. And 1/2 is less than 1. Since we're doing the ratio test, 1/2 is less than 1. Therefore, the series is absolutely convergent. This would be all the details that we need to show the ratio test in operation on this particular series. Like I said yesterday, we're trying to build an instinct about what's going to happen so that we don't have to write all this detail down for the ratio test. We don't want to have to write this down. We just want to be able to conclude that this is absolutely convergent. So it's important to take a look at this and think, what made this limit from the ratio test come out to 1/2? What made that less than 1? What is it about this series that made the limit from the ratio test equal 1? That's what we want to focus on. Not just these individual moves. We want to see the bigger picture of what's going on when we first look at the series. Because the end game is not that you can write down the ratio test to prove that this series is absolutely convergent. The end game is for you to look at this series and know that this is absolutely convergent right away. Know immediately that this is absolutely convergent. If you don't look at, if you get through Calc 2 and you look at this series and immediately know that it's absolutely convergent, wow, I guess I'll run a ratio test. The flow chart says if we see exponential factors, then we should run a ratio test. That is absolutely 100% a huge failure on my part if that's what's happening. What needs to happen at the end of Calc 2, you find this series, you automatically see that it's absolutely convergent. You don't want to have to think about it and write down a ratio test. I don't even care if there's a stall after this point. Someone's like, oh, is this series convergent? And you look at it and you're like, oh, it's absolutely convergent. And put your hands on your hips. Victory. And if you're like, oh, well, why? At this point in your career, you should be like, oh, I don't know, I just know it. All right, feel it. And it's okay if you stumble at this point. It's like, well, yeah, you would do some kind of test on it. What was that friggin' called? And then you would look it up. test for convergence. You know what I mean? That was my favorite argument about math. Well, I'll just look stuff up. Like, all right, I'll hand you a calculus problem and the internet. Good luck, fucker. Well, just look it up. Because right now you're all thinking, I'll just look it up on Wolfram Alpha. Like, but if someone hasn't been really kind of up through calculus, you probably don't know what Wolfram Alpha is. You know what I mean? The professional move, by the way, if you hire someone to do it. That would be awesome. Someone submits some homework to me. Right, I'm taking homework on paper. And it's like all printed out in like a folder. And then at the bottom, it says, this homework prepared for, then your name, by Homework Incorporated. Math Homework Incorporated. All right. Full marks. I hope you got a good prime. I mean, that would be great. Because then if you don't get the score that you want, you can just take it up with them. You don't like come to me and say, well, I think I should have an A. And then you're like, I'm like, why is that? Because I did all the homework. Well, you're supposed to do all the homework. You don't get positive because you did all the homework. You know what I mean? That's what you're supposed to do. That keeps you at 0. Like yesterday, I didn't murder anybody. Where's my reward? It's like, oh, no. Not murdering people is what you're supposed to do. That kept me at 0. The only way to go positive or negative there is that you go negative if you like murder someone, because that's not what you're supposed to do. You go positive if you stop someone else from being murdered, then that's like a win, right? But if you just go through your day and it never comes up, you don't get a reward for that. You're supposed to show up to class every day, or at least online, or at least watch videos, because pandemics and shit. You're supposed to do all of your homework. You know what I mean? What did you do after that? What else did you do? This, of course, has just led to escalation. So like students in high school can't just have A's in all their classes. They have to have A's in all honors classes so they can have a 5.0 GPA. And it doesn't matter that they'll be competing against students who have no chance of graduating with a 5.0 GPA. And yet we still think this is acceptable. You know what I mean? There is nothing that I could have done to graduate with a 5.0 GPA. Absolutely nothing. I could have gone through all 4 years of high school and never got anything wrong. And I would not have a 5.0 GPA. You know what I mean? So then you start looking at the demographics of all the schools where you get a 5.0 GPA, and you start to learn something about the American education system. Anyway, that was all distraction to give you time to look at this series and think, what is it about this series that made this 1/2 show up at the end? And how can I make sure that my conclusion is correct? And then let's test that. So you could probably guess that this 2 showed up just the way that it showed up, because it came from this 2 to the n over 2 to the n plus 1. That 1/2 showed up as a 2 to the n because of the 2 to the n in the denominator of our original series. That's where the 1/2 came from. The n squared, the ratio test never saw that n squared. The ratio test doesn't care about the n squared. The ratio test is blind to rational and radical factors, and this is why. Because the coefficients of the highest powers are always going to be the same, so the limit's always going to be 1 from the rational or radical factors. It's easy to just run the ratio test if you have sufficient algebra skills. It's completely completely unnecessary to have to be able to do that once we can identify what's going on in the series. This is what's really going on in the series. This is what the ratio test tells us. We got to figure out where this 1/2 came from. We're pretty sure it's this 2 to the n in the denominator. Any questions? Yes. Just put it with the n. If there's something that's happening to the n, like n is getting squared, then just put parentheses where the n is and write n plus 1. I didn't do it here with the 2 to the n because when we write exponents, that's like a natural grouping symbol. But if I was writing this, if I had written this, say, as n squared over 2 to the n, then just replace the n's with parentheses, just like you were plugging into a function. And plug in n plus 1. Just replace the n's with parentheses. Oh. And show people what you're writing. So the plus 1 gets attached to the n before anything else that happens to the n. That's the first thing that happens. So we're suspicious that this 2 to the n is what gave us the 1/2. That's what's making this converge. The n squared was not important. So let's just flip that over. If we flip that over, instead of 1/2 for the limit from the ratio test, if I flip over the terms, do we get 2? Let's look at that one. One thing we'll have to note, I can't start the series at 0 if I'm going to write it 2 to the n over n squared. I have to start at 1 because I can't have the first term just be undefined. So remember, this is not just some random problem that showed up on our door that we're going to solve by putting a ratio test on it. There's a reason that we're doing this. If we put the 2 to the n in the numerator, is that going to give us 2 for limit for the ratio test? We suspect. So we are going to suspect that the limit from the ratio test is going to come out 2 in this case. An is 2 to the n over n squared. An plus 1 is 2 to the n plus 1 over n plus 1 squared. So we do an plus 1. And I'm going to multiply by the reciprocal because I don't want to take up so much vertical space. And what we suspected was going to happen, we can see that happening. I've got 2 to the n plus 1 over 2 to the n. So now 2 to the n cancels out, and I'm left with a 2 rather than a 1/2. So 2 to the n, 2 to the n plus 1 divided by 2 to the n. That's going to equal 1/2. Oh, sorry, that's going to equal 2, not 1/2 like we got before. And I'm going to do the same thing with that constant 2. No longer involves n, so I can factor it out of the limit. And then what's left is an n squared over n plus 1 squared. Once again, I can drop the absolute value signs for the same reason we had before. And now because that n squared was the rational factor in our original series, the ratio test doesn't see it. So this limit is equal to 1. So the limit from the ratio test is equal to 2, just as we had suspected. And 2 is greater than 1. So therefore, the series 2 to the n over n squared diverges. Once again, we see the ratio test ignoring the n squared part and focusing on the 2 to the n part. We can also note that 2 to the n is exponential, and we divide that by a polynomial. This limit is not going to go to 0. I used the ratio test here because we wanted to make sure we use the ratio test. We could see what we're reading in the ratio test. The point is not coming up with the most efficient path to concluding that the series diverges. We knew that the series diverged the moment we looked at it. If we want to be efficient, we wouldn't use the ratio test. The best answer would be to note that the limit of the terms is not 0, therefore the series diverges. That would be the best answer. So if I was grading on an A, B, or F scale, A would be to point out the limit of the terms is not 0, therefore the series diverges. The B answer would be to use the ratio test. There's a penalty of 1 grade for excessive use of math. So ref would throw the flag. We have a penalty on the problem. They're not plays, they're problems. We have excessive use of math on the defense. Loss of grade. Next problem. That's a symbol for excessive use of math. We just stand there and write for a while. He's got to have hand signals for everything, despite the fact that they're all wearing microphones. Yeah. What are we talking about? Oh, yes. So what we're trying to do is not, even though it says on the tin, can be used to determine if a series converges or diverges. That is not the point. You want to understand how these factors interact when n is very large. That's the point of what's going on. So in the structure, we mean. We say n factorial, we write n with an exclamation point afterwards. So we write n. We mean, I'm going to use this one, so we don't have to worry about the 0 thing. The number of ways we can arrange n objects. So n factorial is how we say that. We don't shout n. Modern people automatically don't think, well, I wouldn't shout n. If you wanted me to shout it, you would have written it in a capital. Caps is how we make shouting. N factorial. I'm actually okay with the exclamation point as the notation, even though in normal writing, I don't like exclamation point as punctuation. This at the end of the sentence. You like read this whole ass sentence, and only at the end they tell you, you should have been shouting this whole time. And I go, dude, what the hell? Why didn't you tell me up front? Like in Spanish, they put the upside down and say, hey, start shouting. So, all right, this is an exclamation. So tell you at the beginning. With questions, it doesn't really matter, right? You can like be reading the sentence, say, oh no, it's a question, but at the end, just make your voice go up. So you can always like call an audible for the question mark right at the end. You see the question mark coming up at the end of the sentence, like, oh no, it's a question. It's kind of at the end. But the exclamation point says, you should have been shouting this whole time. And I go, you should have told me I should have been shouting at the beginning of the friggin' sentence. You know what I mean? What are we talking about? Oh, yes. We say n factorial. We write n with an exclamation point, and we mean the number of ways to arrange n objects. So 0 factorial is equal to 1. There's only one way to arrange no objects, the empty arrangement. Here, I will arrange 0 Grammy Awards on my desk. There's only one way to do that. Leave the desk empty. The empty arrangement. One factorial is 1. There's only one order we can write put one object. If you are the only person in the race, there is one outcome to that race. You win. 2 factorial. So one object would be just A. 2 factorial is 2, because I can write A and then B, or B and then A. Two arrangements of 2 objects. Three factorial is equal to 6. So I have 2 objects. I've got 3 places I can put a third object. I could put C at the end. I could put C in the middle. I could put C at the beginning. For each of the 2 arrangements I had before, I got 3. But because there were 2 ways to, arrangements before, that gave me 3 places to put a third item. 4 factorial is 24. Oops, I didn't write 6. What did I? Oh, I can have. Sorry. I had 2 arrangements. I didn't do the second one. For each of the 2 arrangements, I had 3 places to put a third entry. Now I have 6 arrangements of 3 items. Each of these 6 arrangements has 4 places we could put a 4th letter. So I can have A, B, C. You know what? I'm not going to. A couple years ago, I came up with a better way of writing this. I could put it first. So I could put the 4th one before the A, in between the A and the B, in between the B and the C, or at the end. So I got 4. I got 4 locations to put D for each of the previous 6. Each one of those has 4, so we multiply. So n factorial is the number of arrangements of n objects. Then we'll talk about the more mechanical way to calculate n factorial. All right, that's going to do it for today. I will see y'all on tomorrow. Have a good day, and thanks for playing.